for the quadratics part 2 test. Certainly the first part of the test, you're going to have to be able to simplify complex numbers. So I to the 19th. Now remember, we're going to take away multiples of 4. So I to the 16th is just 1, because I to the 16th is just 4 I to the 4th, and we all know I to the 4th is just 1. So I to the 19th is really can be reduced to I cubed, and I cubed is negative I, because I squared is minus 1, so then it's just minus 1 times I, which is minus I. Here we're going to rip off 48 of them and get rid of them, leaving us with I squared, which is minus 1. Here we're going to rip off 80 of them, leaving us just 1I. And this is an exact multiple of 4, so they all are just 1 times 1 times 1, which is 1. This is kind of like adding like terms. We're just going to take the real parts after we distribute and combine them, and then the imaginary parts. So I'm going to distribute the negative 2 and get negative 6I plus 8. And I'm going to take the 7 and the 8 and make 15, the 5I and the minus 6I and make minus I. I'm going to remind myself when I do a 5 minus 2I quantity squared that I'm going to write it out as 5 minus 2I times another 5 minus 2I. That'll remind me that I need to FOIL it. So I'm going to get 5 times 5 is 25, negative 2I times 5 is this, negative 2I times that is another negative 10I, and then negative 2I times negative 2I is plus 4I squared. I squared is minus 1, so then this term here, this guy is really just a minus 4. Minus 4 and 25 make 21, and negative 10I make negative 20I. And again, if you look at how I'm writing these, I'm writing them in standard form, which means I write the real part, and then I might write the imaginary part. Right, this is just me foiling 2I and 5, and so on. When you get to here and you have a negative 12I squared, you're going to think of that as just a plus 12, because remember, I squared is just minus 1. And then you take the 12 and the 15 to make 27, and the 10I and the negative 18I to make negative 8I. This one's probably the hardest one. Whenever we have to divide by a complex number, we have to multiply by the conjugate. So we're going to take this sign right here. If this is a plus, you're going to make it a minus. If it's a minus, you're going to make it a plus. You're going to multiply top and bottom by the same complex number, which is called the conjugate. Up top here, we have to FOIL. And then we get these terms, and again, we get an I squared, which we write as a plus 1. And then down here, we get, when you multiply the conjugate, you're going to get a 3 times a 3 to make a 9. You're going to get a 5I and a positive 3, but then you're going to get a minus 5I and a positive 3. Those will cancel. And then you'll also get this 5I times minus 5I, which will be minus 25I squared, but I squared is negative 1, so then this thing is plus 25, which is where the 34 came in. And then when you get here, you do need to reduce. All of those coefficients have a factor of 2, so I can take a 2 out of all of them, and then at this last step, I just separated the real part from the imaginary part. All right. Next question, we have to be able to look at the discriminant. This is the discriminant. It's what's under the square root in the quadratic formula. And we know that if the discriminant of this one is negative, that means we're going to end up with 2 imaginary solutions, because we're going to end up with a plus or a minus the square root of negatives, which we know have an I in them. So we get 2 imaginary. Here, the discriminant is 0. Since the discriminant is 0, we don't do a plus or a minus anything. Right? So we just get the negative b over 2a, and we get 1 real solution. Here, if the discriminant is positive, we're going to get plus or minus the square root of 16, and we're going to get 2 different real options. So if the discriminant is positive, we get 2 real. If the discriminant is 0, we get 1 real. If the discriminant is negative, we get 2 imaginary. Those are the only 3 things that can happen. 2 imaginary, 1 real, or 2 real. All right, now we're into solving. So I'm going to subtract 25, then I'm going to take a square root. I'm going to reduce the square root of 20 like I always would. The negative under the square root just becomes an I, and I get it like this. Real part, then imaginary part. If you wanted to put the I out here, that's totally fine. You can put it here, but it is just chilling on the end, and that's where the negative 1 comes in. Quadratic formula, you do have some fractions here. Probably the only hard step is to remind yourself that when you end up dividing by a fraction, you do multiply by the reciprocal. So if I divide by 7/2 is the same thing as multiplying by 2/7, which is why in my final answer, the 5 went to a 10 and the 3 went to a 6, because I multiplied by 2 because of that guy. Completing the square, same process. Let's move everything to the left side except the numbers. The magic number is 1, so I added 1 here and I added 1 here. I added the perfect number to this to make it a perfect square trinomial, so it factors to x minus 1 squared. And then I end up taking the square root of -8. Remember, 8 is 4 times 2. The square root of 4 is 2, which is where this 2 comes from. This 2 has to chill, and then the negative becomes the I. Solve by factoring. This is just reminding you that if we have the sum of two squares, it will not factor into real numbers. You have to use imaginary numbers, right? You have to use plus and minus 9i. When you think about it, the 9i in the x will cancel with the negative 9i in the x, and then 9i times minus 9i is minus 81i squared, but I squared is -1, so you get back to plus 81. That's the weird part, right? Because if you end up with a plus 81 here, the only way you can do it is with imaginary numbers if you're going to end up getting these things to cancel. Okay? All right. This is writing the equation. So if I give you x-intercepts, you immediately know those two factors. If you know that x-intercept is 4 and -6, you can write that, but you're not sure what a is. But you can use this point to find a. So just plug 10 in for y, -2 in for x here, and then solve for a. And then once you know a, you can plug it in here. And then once you get this, if I want it in standard form, well, you're going to have to multiply and distribute. And that's where you get this. This is the final answer written in standard form. Y equals ax squared plus or minus b plus c, right? Same thing here. If you know the vertex, you can immediately write it in vertex form. You're just not sure what the a value is, but you can use the additional information, plug in this for y, this for x, and then find a. Once you know a, you can plug it back in for a, and then you get to this point, and then you have to distribute, making sure that you FOIL out the x minus 3 squared to x minus 3 times x minus 3, FOIL it, distribute, and combine. This one's all about your calculator. You're just going to plug these 3 points into, You're going to plug these 3 points into L1 and L2 in the stat list. Go calculate, and you're going to do a quadratic regression rather than a linear regression, and it will tell you values for A, B, and C. This one is kind of fun. There's a whole bunch of different answers, but if you have no real solutions and a y-intercept of 10, that means like you're a smile that has a y-intercept of 10, and you never go through the x-axis, which means you have no real solutions. You must have two imaginary. All right, story problems. 3 consecutive even numbers. Okay, first thing you're going to write down is that. That is a variable expression for each of the numbers. X, x plus 2, x plus 4. Then I want the product of the second and third one. Okay, product is multiply. Is equal sign, 18 more, 18 plus, 1.5 times the square of your first number. The square of your first number is x squared. Once you get here, you've successfully changed the English sentences into math. At that point, we distributed. You see how here you have a 1.5x squared? I don't like that decimal. I want to get rid of it. So I actually multiply everything by 2 to get rid of the decimal. And then at this point, I factor like normal. Okay, and I solved, and you end up with 2 solutions. These 3 numbers work, and these 3 numbers work. And you can check them. You can make sure that if you take the, 4 times 6 is 18 more than 1.5 times 2 squared. And that is true. Okay. Area perimeter type 1, you got a farmer with a rectangular plot of land. The first thing when you read that sentence, draw this picture. Just draw a rectangle. Then it says the length is 5 more than 3 times the width. Okay, let's call the width x, and then we can call the length 3x plus 5. And if I know the area is 350, I can write this equation because I know that area equals length times width. Multiply it out, get a quadratic. Looks like I solved by factoring, and I can get the dimensions. The dimensions are the length and the width. And then you can check your answer if you want. This is 5 more than 3 times the width, and if you multiply them together to find the area, you get 350. All right, the last one is this border question that they love to ask. You got a pool, it's 18 by 20. This right here is kind of your pool, that's where the water is, and you're gonna add a border of concrete, and you want to double the area. Okay, so your original area is 360, your new area then is 720, and our new area, we know that this length is 18 plus 2x. This length is now 20 plus 2x. So you write that equation, distribute this side by foiling, get everything on one side, and you either have to factor it, complete the square, or use the quadratic formula. And in this case, I just used my calculator, and I got that for the width of the border. Okay, so as a reminder, this is a good review of the test. Story problems, writing the equation of a quadratic, solving with imaginary numbers, discriminant ideas, simplifying complex, and then all of the old stuff is still fair game. So factoring, quadratic formula, completing the square, solving using square roots, all that good stuff. Okay, hopefully this video helps you study for your test.